Dear 10th grade student, how are you? My name is teacher Hala. We are going to learn a new lesson, which is total internal reflection. Before starting this lesson, we will make a small revision for refraction. We know before that refraction takes place because light travels from different mediums or between different mediums. Okay, in this case, the light ray travels from water to air. So the light ray will refract. Why it will refract? Because light ray or the speed of light ray will change. It started from low speed to high speed. So refraction will occur. So refraction occurs when the light ray travels between two different mediums. Also, this refers to changing in the speed of light ray. This is the reasons of refraction. Total internal reflection. Firstly, if we have this light ray incident normal to the surface, what happened to the refracted ray? In this case, there is no refraction occur. The light ray will straight forward without any refraction. But if we increase the incident ray or incident angle, what happened to the refracted angle? Yes, refracted angle also will increase. So by increasing the incident angle, refracted angle also will increase. What happens if we increase the incident angle more? Also refracted angle will increase more. So directly proportional between the incident angle and the refracted angle. By increasing incident angle, the refracted angle will increase. Now, we will increase the incident angle till reach to the critical angle. When we reach the critical angle, the refracted angle will equal 90 degrees. So, critical angle appear when the refracted angle equal 90 degrees. In this case, increasing angle of incidence more, critical angle reached, and energy is transmitted along the boundary layer. When energy transmitted along the boundary layer, it means the refracted angle equal 90 degrees. Okay, so total internal reflection started with when the light strikes or incident normal, no refraction. By increasing the incident angle, the refracted angle increase also. Till reach to critical angle, the refracted angle will equal 90 degrees. But what happens if we increase the incident angle more than critical angle? What happened to refracted angle? What happened to the refracted ray? In this case, the light ray will reflect. So by increasing the incident angle more than critical angle, reflection will occur. So it's called total internal reflection. In this case, total internal reflection occurs by increasing the incident angle more than critical angle. So if I ask you, how can we reach to total internal reflection? We have two ways. First one, when we use first medium more dense than second medium. Second reason or second way, when the incident angle become more than critical angle, total internal reflection will occur. It is very important. Total internal reflection occur because of two reasons. First one, when we use two mediums, first medium more dense than second medium. Second reason, when the incident angle become more than critical angle. Okay, understood? Critical angle. How can we calculate critical angle? Now we will use two mediums, which are glass and air. The critical angle for glass is 42 degrees. So refracted angle for second medium will be 90 degrees. Okay, to calculate the critical angle or to write the formula of critical angle, we will start with the refractive index formula. If you remember this formula, N equals sin R over sin I. N refer to refractive index, sin R refer to sin refracted angle, sin I refer to the sine of incident angle. But in case of total internal reflection, or in case of critical angle, sin R will be sin 90 because reflected angle equal 90. Incident angle will called sin C, which is a critical angle. So it will be n times sin C equal 1. For 1 from where? Sin 90 equal 1. So instead of sin 90, we will write 1. So sin C equal 1 over n. Sin C is referred to sine critical angle. So sine critical angle equal 1 over n. N is the refractive index of the medium. Okay, so we can calculate the critical angle by using this formula. Sin C equal 1 over n. Now we will discuss some applications on total internal reflection. Total internal reflection has many applications. First one, optic fiber. Optic fiber is cables made from plastic or glass. Okay, optic fiber has a critical angle very small, so refractive index very high. Fiber optics made from plastic or glass. Okay, with a small critical angle, so its refractive index will be high. Light enter will always have an angle of incidence greater than critical angle. So when the incident angle more than critical angle, what happens? Total internal reflection will occur. Now we will know the advantages of fiber optics. Fiber optics has many advantages. Same, the signal are not affected by electrical storms. Same, the copper cable. Okay, the signal that carried by the optic fiber does not affected by electric storms. Also, optic fiber is smaller and lighter than copper cables. Okay, also more signals can be carried over longer distance. So optic fiber has many advantages more than the copper cables. First one, signals are not affected by electric storms. Also smaller and lighter than the copper cables. More signals can be carried over longer distance. This for advantage of optic fibers. Second application of total internal reflection is endoscope. Endoscope is a device which used by doctors to see inside the body. This device can be used to diagnose the cancer. An endoscope is a flexible fiber optic cable through which internal cavities can be viewed. Okay, routinely used to diagnose cancer. This picture shows doctor use endoscope. Okay, he want to know or he want to diagnose that cancer which inside the lungs. Okay, this for endoscope. Now we will solve some questions about our lesson, and I hope to be understand. First question. A glass has a critical angle of 41 degrees. Explain what happens when angle of incidence equals 50 degrees. Okay, in this question he give us the critical angle of a glass, which is 41. What happens if the incident angle become or equal 50 degrees? Before answering this question, we should concentrate. In this case, the incident angle, same critical angle or more than critical angle? Yes, it is more than critical angle. So the incident angle more than critical angle, what happened? Yes, very good. Total internal reflection will occur. Second question. Calculate the critical angle in diamond if the refractive index of diamond is 2.42. 2.42. Okay, to calculate critical angle, what will we do? We will use the formula of critical angle, which is sin C equal 1 over n. Sin C is unknown, so we will write sin C equal 1 over n. And refractive index here equal 2.42. So sin C equal 1 over 2.42. Sin C will equal 0.41. To calculate C, we will take inverse sign for 0.41. inverse sign, we can do it by calculator. Shift sign give you inverse sign. Okay, so the angle or critical angle will equal 24.4 degrees. Hope to be fine and hope you to understand, hope you also to study well this part. Okay, try to solve this homework. Okay, and if you have any questions, please send on the website of the school. Thank you for Mr. Yunus to give us this chance to continue in our syllabus. Thank you for all.